Okie dokie. So this is a related rates problem. So what we've got going on here is we have a cone and it has water in it, and the water is dripping out at a rate of 7 cubic meters per minute. The height of the cone is equal to 2 times the radius. That's important for solving this problem. And we want to know the rate of change of the height when the depth is 4 centimeters. So when we start these problems, we want to start with the rate at which we're trying to achieve. So we want to find the change in height, dh, over at a certain time. So we want it to be a rate, so we're going to put time on the bottom. And so this is our rate we are after, dh dt. So then when I do these problems, I think about you split them in a proportion and you multiply them together. So dt, I shoot away over here to this side, and the top one moves across. And so then there's going to be something that is the same on both of these that we'll be able to cancel out. And that's how we get this. And so this falling is going to be a change in volume over a time. So this 7 centimeters right here, that is my dv dt. And so this is going to be dv as well. So the change in height and the change in volume. And I can source that from the formula for the area of the volume of a cone. So it's going to be the volume equals 1/3 pi r squared times the height. And because I know that the height equals 2 times the radius, the height over 2 is going to equal my radius. So I'm going to be h over 2 squared times h times pi times 1/3 is going to equal my volume in terms of h. So now I'm going to multiply this out, so I get h squared over 2 times h times pi times 1/3, and that's going to equal my volume as a function of my height. So now I'm just going to multiply these all together, and this 2 turns into a 4. When we square it, the square is going to go to both the h and to the 2. So 2 squared is 4, h squared is h squared. And so I have h times h on top, so that's going to be h cubed times pi on top, and then the 3 and the 4 are going to multiply as well to give me 12 on the denominator. And that's going to be my v of h. So now what I want to do is take the derivative so I can get dv over dh. And to do that, I'm just going to take this 3 power rule, so 3 pi h squared over 12. The 3 and the 12 cancel, giving me pi h squared over 4. But I want dh dv. So to get dh dv, I'm just going to flip this over. So dh dv is going to equal 4 and then pi h squared. And this is centimeters squared because we had a volume function. So volume would be cubic because it's 3D, and then by taking the derivative it gets knocked down to squared also. So the units do track through the same process in that similar manner. And so what I did here, I have dv over dh, so pi over h squared over 4. So see how the dv and the dh switch places from numerator and denominator, and we just did that with the equation as well to get from here to there. So now what I'm going to do is plug it all in. So I'm going to have 4 over pi h squared centimeters squared, and that's going to be multiplied by 7 cubic centimeters per minute. That's this rate right here. And that's going to give me my answer. And I want the rate of change at a depth of 4 centimeters. So I'm going to plug 4 here, 4 squared times pi over under 4. The centimeter squared is going to cancel out with the centimeter cubed to give me centimeters over per minute. And then I just have a 7 on top. Centimeters per minute. And so now I just multiply, so I get 28 over 16 pi centimeters per minute. And then I cancel out, so that's turned to 14 and 8, and then that's 7 over 4. So I have 7 over 4 pi centimeter change per minute. And so that's the rate at which the height is changing when it is 4 centimeters. And so that's kind of how you'd step through that problem. Some things to know about related rates. We wanted to get here, and then you just hunt after what you want. One's usually going to come from a formula, which would be this one, and the other one's going to be given to you. But being able to say, this is what I want, and then break it apart, and then fill these in, and then multiply it out, and put in the number if you have one, and that's how you the general thought process you should take when going through one of these problems. I hope that was helpful.